In this video, we'll start coding a gameplay loop so we can have some movement in our project. So I'll start by developing the movement of the main character, which is the cube here. The movement is simple. The character will only be able to go from left to right in order to avoid obstacles like this. We'll do that right now. I go to the scripts folder here. I do right click, create C# script, and I call it player. This will be the script that will be attached to the player. I take it and drag it, then I double click on it to edit it. Now, we have access to the code to create our first character movement function. So I won't need the start function, so I delete everything to keep only the update function, which will be used to detect the movement. To move the cube, the player will touch the screen. He will put his thumb on the screen, and by moving his thumb from left to right, he'll move the player from left to right. And to handle this, I need several things. We'll start by creating a private variable, which means that the variable will not be visible in the inspector. I'll create a touch type variable, which is a component of Unity, a class that allows you to manage the touch screen. So I'll call this variable of type touch, well, touch, keep it simple. That's the first variable I need. I need a second variable, which will be public this time, of type float. It will be the speed. It will be the speed of the character's movement. And then I'll need two other float variables, which will be pos_x_min, which is the minimum x-axis position, and pos_x_max, which is the maximum x-axis position. I save and just go back into Unity. We wait for it to compile. And normally, if I click on the cube and look at its components, we'll find the script player here with the three public variables that we created. For the movement speed, I'll put a very small value, 0.01 for example. Why so small? Because nowadays screens have a lot of pixels and Unity's touch is not necessarily very precise if you have large values. Each pixel offset corresponds to a movement of the cube, and by setting a very small value in the speed, I'll be able to try to make the movement of the cube correspond more or less to the movement of the thumb on the screen. Otherwise, if you don't set a small value, if you move your thumb from here to here, then the cube will have moved 100 meters to the right, for example. What I want is that if you move your thumb from here to here, the cube will move from here to here, approximately. It doesn't have to be extremely precise, but we need a small value. Then I'll block the cube on the axis here, so that we can't get out of the road. I just check where the cube is. Here it's at 0 on x, and if I go here, it's at minus 1.5, and here it's at 1.5. Very well. Minus 1.5 and 1.5. So the minimum position on x will be minus 1.5, and the maximum will be 1.5. That's it. I've set the two values correctly. We can double click on script player to return to the script player and continue writing the scripts. We'll start by creating a condition. If, and between brackets input dot touch count, this is the number of places where you touch the screen. If we just have our thumb on the screen, then it will return 1, and we'll say if the number of places where we touch the screen is greater than 0, that means if the player has put his finger on the screen, then we'll execute something. So if the player has at least one finger on the screen, so we'll start the movement on the cube. So what I need here is to retrieve the current information from the input. I need to know, well, where to retrieve the position of the finger on the screen. Here we created a touch type variable that contains all the information about a touch, and I say that touch is equal to input.getTouch, and in brackets I specify which finger I want to retrieve, and I'm like 0, which corresponds to the first finger placed on the screen. So if you touch the screen, I get the first finger that was placed on the screen, which means that the others will be ignored, or at least not used for this movement function, but nothing prevents you from doing a pinch to zoom. That means pinching the screen to be able to zoom in or out. But in short, what I want is to get the first finger on the screen. So we get the information, just writing comments, French. We get the information from the first finger placed on the touch screen. We store this information in touch, which is our variable touch here, and then we will test if the player moves the finger. To do this, we'll do if touch, touch being our variable, touch.phase, phase being the different possible states. So if touch phase is equal to touch phase dot moved, you see we have several possibilities, begun, cancelled, ended, stationary. So for us it's moved. That means if the finger moved on the screen, at that moment we can execute a specific code if this event occurred. So if it has happened, we move the cube following the movement of the finger. And to do this, to move the cube, it's just transform.position, and that's it. Transform.position allows you to access the position of the cube. If I go to Unity, the script being attached to the cube, as you can see here, transform.position means that we access transform here, that the first component in the list. Transform.position, this property. Knowing that the Y and Z position will never move, we just need to change the X to be able to apply a movement like this. That's what we'll do here. I'll state that transform.position is equal to something, and what I'll do is say new vector 3. It means that we create a new vector 3. It's X, Y, Z, it's a vector with those 3 values. And we say that our position is equal to a new position in the 3D world, X, Y, Z. And this new position will be equal to the next one. It will be equal to transform.position.x, transform.position.y, and transform.position.z. So what I've done doesn't mean anything for now. It just means that my position is equal to a new position, which is exactly the same, since I'm saying that it's equal to itself, in fact. I say that it is equal to my position on the x-axis, y, and z, so nothing has changed at all. But now that we've broken down our position here into 3 x, y, z values, I'll be able to change the position specifically for the x-axis value. So, to change the position on the x-axis, I want to add the finger position variations on the screen. So I want to actually add the touch here, this one, dot delta position. Touch dot delta position is the variation of the finger position on the screen. So I want the X position of the cube to be based on the movement of our thumb actually on the screen. Dot X because Y doesn't matter, so I just want the delta position dot X, which will allow me to add to the cube the variation of the finger position. Knowing that by default your finger is in coordinates 0, 0, if you move to the right your finger, well, the position will have a positive value. If you move to the right, it will be positive. Well, I'll try to represent that. If you remember your math class, we have the y coordinates, the x coordinates. By default, when we put our finger on the screen, at the moment we put our finger on the screen is here, so in 0, 0. If you move your thumb to the right, it will have a positive value. And if you move it to the left, it will have a negative value. So I'm adding something that can be either positive or negative. If it's negative plus minus, well, that's minus. So we're going to calibrate the position of the cube according to the finger, and we'll multiply it by speed. Remember, speed is our variable here, which is the speed of movement that we want in order for everything to be well calibrated. Now, normally that's all we need to do. We can do Ctrl S to save, and then we'll test it. I'll go back to Unity. I'm gonna increase this a little bit, like this. I go back to Unity, and since we've created a game, a mobile project, and we're on the simulator, it's a little novelty, but now we can test as if it were a real touch screen. Meaning, if I start the game, my mouse is considered as the touch on the screen, and there you see that I can move the cube on the screen with my mouse. You notice there's a problem. I can go to the limit of the field. But we'll be able to fix that later with the two variables we created in our player script. So here, we move the cube, and here, just below it, no, I'll put it in there. So we're gonna block the cube between, so block the cube between two values on the x-axis. And we'll just do an if transform.position.x. So if the position of the cube on the x-axis is smaller than the minimum allowed position, which is here, so if the position on the x-axis is smaller than the minimum allowed value, we'll say transform dot position is equal to new vector 3, etc., like this, like here, except that on the x-axis we will say that is equal to minimum position. This means that if we go beyond, this value will be stuck on the minimum position here on the x-axis. And I'll do exactly the same thing for if the x position is greater than the max position. At that moment, I'll block the position in x, having the value of a 0.5. That's what we define for our project, 1.5. We save. Go back to Unity, we wait for it to compile, always takes a little while. We launch the game, and now our cube should not be able to leave the zone that has been authorized, as you can see. Now the cube stays on the road. Here we are. We have created our first piece of code that allows us to interact with the game and to modify the position of the player on the screen. Just to clarify, you can see that here I'm moving my mouse to the right and I'm moving it to the left, and you can see that the movement of the cube is much more important than the movement of my mouse. I only move the mouse a little bit and the cube moves much more. This is exactly what I told you about our speed variable. That's exactly why we created our speed variable. If I hadn't made the speed variable, look what would have happened. If I set speed to 1, you'll see I'm going to move the mouse a little bit and the cube is actually hundreds of meters away, which is not playable at all. You can adjust this variable speed to find values that you like. And it may take a little time to find the right one, but like there, for example, it's not too bad. Okay, if I leave edit mode, it will delete what I was doing. But if you make your changes while you're not playing, your changes are kept. So now you can play around with the values a little bit to find something that works for your project. For me, I think I'll stay like this. And I'll stop here for this video. We'll have set up the character's movements so that he can slalom, and what we'll do next is take care of the obstacles that will come and move towards us in order to eventually destroy us. So see you in the next video.